The mass spectrometry method is based on the spatial or temporal separation of pre-ionized molecules that differ in mass. The separation takes place under high vacuum conditions in electric and magnetic fields, and is aimed at determining the masses of molecules, atoms, and the relative content of components of different masses in the analyzed substance. Mass spectral analysis is reduced mainly to the following operations. 1. The transformation of atoms of matter into positive ions. 2. Creation of an ion beam or groups of ions in a static or pulsed electrostatic field. 3. Spatial or temporal separation of the flow of particles in magnetic and electric fields. 4. Separate measurement and registration of the intensity of each flow component. The main components of mass spectrometry devices. The principle by which the analysis is carried out determines the presence of the following main components for each mass spectrometer. 1. An ion source in which neoformation and formation of a beam or groups of particles takes place. 2. Mass analyzer, where the generated flow is divided into components that differ in the ratio of their mass to charge. 3. Devices for capturing and registering particles. The principle of operation of the devices is to measure the intensity of the ion current of each component. In addition to the listed main units, they also contain vacuum systems with pumps and valves for obtaining high vacuum, pressure gauges, systems for preparing and introducing the analyte into the ion source, electronic power circuits, mass number indicators, current and voltage stabilizers, etc. The history of mass spectrometry begins with the fundamental experiments of J. Thomson at the beginning of the 20th century. The ending metria in the name of the method appeared after the widespread transition from the detection of charged particles using photographic plates to electrical measurements of ion currents. A spectrograph differs from a spectrometer in that the entire region of the spectrum available in a given system is recorded on a photographic plate. When using a spectrograph, a qualitative analysis is carried out by checking for the presence of several lines of a particular analyte, and a quantitative analysis is performed by measuring the intensity of the lines with a microphotometer. Although spectrographs are still in use, they have been pushed out of the market by spectrometers. Thomson decided to measure the mass and charge of these new beams, also using electric and magnetic fields to deflect the particles. His apparatus for studying positive rays, the mass spectrograph, is shown schematically in Figure 2. It differs from the device shown in Figure 1, by the fact that the electric and magnetic fields deviate the particles at right angles to each other, and therefore it is not possible to obtain a zero deviation. Positively charged atoms on the way between the anode and cathode may lose one or more electrons, and for this reason may be accelerated to different energies. Atoms of the same type with the same charge and mass, but with a certain spread in final velocities, will draw a curved line, a segment of a parabola, on a luminescent screen or photographic plate. In the presence of atoms with different masses, heavier atoms, with the same charge, will deviate from the central axis less than lighter ones. On Figure 3 shows a photograph of parabolas obtained on a Thomson mass spectrograph. The narrowest parabola corresponds to the heaviest singly ionized atom, mercury atom, which has one electron knocked out. The two widest parabolas correspond to hydrogen, one to atomic H+ and the other to molecular H2+, both of which are singly ionized. In some cases, 2, 3, or even 4 charges are lost, but atomic hydrogen has never been observed to be ionized more than once. This circumstance was the first indication that there is only one electron in the hydrogen atom, i.e. it is the simplest of atoms. For the first time, a mass spectrograph was used to determine atomic masses by F. G. Aston, 1919. In 1928 to 1939, Aston improved his instrument. Atomic masses were determined by him with an accuracy of thousandths of a percent.